You've probably heard of the Y2K bug, right? Well, today, we're going to talk about its lesser known, but maybe even more interesting sequel. It's a hidden digital deadline, a ticking time bomb that's built into the very foundation of so much of our modern world. In fact, this problem is potentially so disruptive that some programmers have given it this perfectly dramatic nickname, the Apocalypse. And yeah, it sounds like something straight out of a sci-fi movie, but trust me, it's a very real software bug. So what exactly is this problem? Well, imagine this. At precisely 7 seconds past 3:14 in the morning, Universal Time, on January 19th, 2038, countless computers could just glitch. And I don't mean they'll just crash. They'll suddenly think it's December 13th of 1901. It's a 1-second jump that sends them rocketing back 137 years. The real question is, why?
Okay, to really get what's going on, we need to officially introduce the year 2038 problem. And if this is giving you major flashbacks to all that panic around the year 2000 bug, you are absolutely on the right track. Both of these problems boil down to a really simple fact. Computers have limits on how they store and read dates. You can think of it like an old car's odometer, you know? It just keeps counting up the miles. But eventually, it's gonna hit all nines, and then what happens? It rolls right back over to zero. A lot of computer systems have a very similar limit for how they count time, and we are getting closer and closer to that limit. So let's dive into the technical heart of this thing. How do our computers actually keep track of time in the first place? Well, for a huge number of them, it all comes down to a system that became the standard decades and decades ago. It's called Unix time, and honestly, you can just think of it as a giant, universal stopwatch. Someone hit start at midnight on January 1st, 1970, and it has been counting up second by second ever since. It is used in countless operating systems and devices, which means for a ton of systems out there, the current time is just one very large number. Okay, now here's the catch. In a lot of older 32-bit systems, that giant number of seconds gets stored in something called a 32-bit signed integer. Just think of this as the container for the time. And, well, that container only has so much space inside. And this is the limit. The biggest number that can fit into that 32-bit container is just over 2.1 billion. That is the odometer's absolute maximum value. So once that Unix stopwatch ticks 1 second past this number, things get really weird. And you can see exactly what happens right here. At 03:14:07, on that day in 2038, the counter hits its max. 1 second later, there's no more room. The number overflows. It flips from the biggest positive number it can be to the biggest negative number. The computer sees this negative number and interprets it as a time way before the stopwatch even started, specifically late in the evening on December 13th, 1901.
All right, so we get the how and the why. Now let's talk about the what. Where are these digital time bombs actually hiding out in the real world? Your new laptop or smartphone? They're probably fine. The real risk is in all the invisible technology that surrounds us every day. We're talking about embedded systems, those little computers in your car's brakes, in airplane navigation systems, even in your Wi-Fi router. Then there's all the legacy software, older databases and file systems that were built decades ago but might still be running some really critical infrastructure. And what's wild is that this isn't some far-off theoretical what-if scenario. The year 2038 bug has already started causing real problems for software that has to calculate dates way out in the future, like trying to set a long-term expiration date or something. Oh, a classic example happened way back in 2006. AOL's web server software had this feature where you could set a request to never time out. And the way the programmers did that was simple. They just set the timeout date really far in the future, 1 billion seconds to be exact. The problem was, in May of 2006, 1 billion seconds from then was a date after the 2038 limit. The calculation overflowed, came back as a time in the past, and made the software crash instantly. So, if this digital doomsday just inevitable, are we all doomed? No, not at all. The really good news is that for years, brilliant engineers have been working on a solution to stop the apocalypse, and the fix is actually really elegant and incredibly strong. At its core, the solution is pretty straightforward. If your 32-bit container for time is too small, what do? You just build a much bigger one. Engineers are moving systems from using a 32-bit integer over to a 64-bit integer to store that big count of seconds. And when I say bigger, I mean astronomically bigger. A 32-bit integer can hold about 2.1 billion seconds.
a 64-bit integer, it can hold over 9 quintillion seconds. This isn't just a small upgrade, it's a massive fundamental leap in capacity. So how long will that new 64-bit counter last? Roughly 292 billion years. Yeah, you heard that right. To put that into perspective, that is about 21 times the current estimated age of the entire universe. I think it's safe to say we've kicked this particular can a long, long way down the road. And this transition isn't just a plan, it's already well underway. Modern 64-bit operating systems, Windows, macOS, Linux, they're all made the switch. Programming languages, databases, network protocols, they're all being updated. They're even finding really clever ways to patch some of those older 32-bit systems to get them ready. But this brings us to the final, and maybe the most difficult, part of the entire puzzle. What about the systems we can't easily update? The code that we might have completely forgotten about. Look, the big mainstream systems we use every day are on track to be perfectly safe. The real challenge is all the small stuff, the millions and millions of embedded devices in our infrastructure, in our cars, in factories. A lot of those were designed to be installed once and then just run, completely untouched for decades, which makes updating them difficult, or expensive, or maybe even impossible. So while the apocalypse has probably been avoided for most of us, the year 2038 problem leaves us with this really fascinating question. We are busy upgrading the digital world that we see and use every single day. But what about all that invisible, forgotten code that's quietly running in the background? What happens when its time finally runs out?